Hi there, welcome to an introduction on integration by substitution. So, probably the last thing you learned about integration was the power rule. It's when we have, let's say, we're integrating the function x squared with respect to x, right? All you need to do is raise the power on the variable to one more than it was before and divide by that new power. So this is going to equal, right, x squared, we add 1 to the exponent, so 3, divide by that new exponent, and we gotta kind of tag on this plus c here. So it's not nothing too crazy. That only works though for polynomial functions. Integrating by substitution works for another super specific condition. So this isn't kind of the only way to solve integrals. Like the majority of times, you're not going to be able to use substitution. But if you see this specific condition that I'm going to talk about, then substitution is probably the way to go. So see how kind of embedded in the square root we have x to the fourth plus 3, and then on the outside it's being multiplied by x cubed, which is a power 1 less than x to the fourth. So keep that in mind, that's pretty important. We always set the higher exponent, right? This is x to the fourth, and this entire kind of expression that's embedded in the square root, we set that equal to u. Okay, so this is x to the fourth plus 3. Okay, so the way it is right now, we have an integral of x cubed times the square root of u dx. Now, let's try and think of a way to make this dx du. Okay, what if we wanted this to be du? Because we want all the variables to stay the same, right? So to find du, well, let's take the derivative of u. So du by dx, what's the derivative of u with respect to x at any given point? So all we do is we differentiate this guy right here. So this is going to be 4x cubed, right? Now if we solve for du, we just multiply both sides by dx. So du equals 4x cubed dx. So remember before this was a dx. If we want to change it to du, well, we can't just put du here because du is not just equal to du, it's 4x cubed dx. So if we did put du in there, that would be the same as taking the integral of, right, we have our root u times 4x cubed dx. So how does this vary from what we had before? We only had one x cubed over here. Now we have 4x cubes. So if we want to put in du, we have to take 1/4 times du. Because if we had a fourth of du, right, this 4 up here would disappear, and we would just have x cubed dx, which is exactly what we want. So if we put in du, we got to take a fourth of the entire thing. So this is 1/4 times root u du. Okay, that's super important. And if we kind of factor out this constant 1/4, right, with integrals we can take out the constants. 1/4 times the integral of u du. So we went from something that looked super scary and we made it into this seemingly simple looking function just by calling u x to the fourth plus 3, right? That's what's kind of embedded inside the square root, and it has to be multiplied by um, a power of x that's 1 less than what u is, right? So the degree of u is 4, right? Because we have an x to the fourth. The degree of what it's being multiplied by on the outside has to be 1 less, so the degree had to be 3 there. We found it was 4x to the 3. We said, well, in our original function, it was just 1x to the 3. So if we take the derivative of u with respect to x, we get 4x cubed. Du, by multiplying dx on both sides, we get 4x cubed times dx. We don't want 4x cubed, so all we did was we took 1/4 of du, right? Because if we write this in terms of x, this is going to be 1/4 times the square root of 4, or sorry, the times the square root of um, x to the fourth plus 3, right? And then that du was 4x cubed dx. So see how we have the 1/4 and the 4? That's going to cancel out there. So we could rewrite it as the square root of x to the fourth plus 3 times x cubed dx. And this is exactly what we had originally. So just by taking 1/4 of du, we're able to factor out that 1/4, and it just kind of cleans it up a lot more. Now, if we kind of finish this question off here, we haven't even evaluated the integral. We kind of like just set it up in terms of u. So now if we actually evaluate it, well, now we can use the power rule, which I know lots of people like doing. So we have 1/4 times, what's the antiderivative of the square root of u? So let's just think the square root of u is the same as u to the 1/2 power, right? du. So if we raise u to the 1/2 by a power of 1, 1/2 plus 1 is 3/2. So this is going to be 1/4 times u to the 3/2, right? And then we have to divide by that new power. So divide by 3/2, right? And then we got to have that plus c on there. Okay, so if we divide by 3/2, that's the same as multiplying by 2/3. So this is 1/4 times 2/3 times u to the 3/2 plus c. Okay, so 1/4 times 2/3, that's, right, we multiply 1 and 2, 4 and 3, so that's 2/12. That's 1/6 u, whoops, u to the 3/2 plus c. Well, what's u to the 3/2? That is the square root, right? 1/6 times the square root of u cubed, and then we got that plus c on there. Now, after all this, we have to substitute our original relation in for u, right? Because u isn't even in the question, right? Originally, it was just in terms of x, so we found that u was x to the fourth plus 3. So as soon as we solve for the integral in terms of u, we have to kind of plug back in our u. So x to the fourth plus 3 cubed plus c. And now we've evaluated the integral. And as you can see, if we didn't perform the substitution, there's no way that we could solve for this integral using the power rule, right? We could eventually, after substituting in u, right, because we know the square root of u is the same as u to the 1/2. We can use the power rule there, but the important thing is when you can't use the power rule immediately, always look to see if you can use substitution. Okay, so that's just kind of an introduction. They do get a lot harder. There's some more difficult examples I'll go through with you in other videos, but that's just kind of an introduction. And like I said, also when you're integrating definite integrals by substitution, there's a certain process you have to go through. I'll explain it in the next video, but yeah, see you in the next one.